My name is Dr. Jürgen Fischer. I am a technical sales and application manager at Fiberstar. In this video, I will be talking about citri-fi and the gelling properties of this citrus fiber. Citri-fi is not just a byproduct of the pectin industry, and therefore our product is still rich in pectin. As you know, pectin is an important gelling agent, and I like to show you what citri-fi can do. Let me start with some background information on pectin. Pectin is located in plant cell walls and part of a very complex structure. Especially the soft, non-woody parts of plants are high in pectin, where it helps with keeping the shape and moisture control. The main component, the backbone, is a polymer of galacturonic acid units. Pectin-rich cell wall material serves as source of the commercial pectin production. The most important raw materials are byproducts from the apple juice and citrus juice industries. Typically, dried apple pomace or citrus peels are used to extract the pectin, and this is normally done by treatments with acids and precipitation by solvents. Commercial or isolated pectin as food ingredients is defined to be a polymer of at least a galacturonic acid content of 65%. The acidic groups can be free or esterified. This degree of esterification is important for the technical functionality, especially the gelation. Due to the gelling conditions, pectin is divided in two principal groups. HM pectin has more than 50% methyl ester groups. The gelling is by a sugar-acid principle. Under acidic conditions, carboxyl groups are not dissociated, sugar binds water, and the polymers can form junction suits. The hydrophobic interaction between the methyl groups support this binding. Keep this in mind because this natural pectin type is present in citri-fi. LM pectin, on the other side, has less than 50% methyl ester groups. Instead of hydrophobic binding, the polymers can form gels via bivalent cations such as calcium. The gelation works also under low sugar conditions. So what is citri-fi? Citri-fi is a pectin-containing product from cell wall material of citrus fruits obtained by physical processing steps. Citri-fi is linked to the juice industry and is not a product from the pectin production. A key difference to other citrus fibers. Therefore, our product is only minimal processed and not treated by chemicals or solvents. This is an important fact if we speak on natural fruit products. Our product is made by a very sustainable process. We use either fresh citrus pulp or, if not available out of the harvest season, dried cell wall material is used to produce citri-fi. Since the raw material is coming direct from the citrus juicing industry, citri-fi's holistic composition contains about 40% native pectin. In the nutrition analysis, pectin shows up as a soluble dietary fiber and to a little extent also in the insoluble fiber fraction. It is important to mention that Fiberstar's patented technology opens up the tightly compact cell wall structure and creates a high surface area. As you can see here, the electron micrograph shows what citrus material looks like before it is processed and after the material is passed through our process. This provides significantly more touch points and devices for water binding and make pectins available for the specific functionality. In the next slides, I will show you more details under which conditions you can benefit from the gelling properties of the native pectin. On this picture, you can see 2% citri-fi at 60 bricks in a test system using apple pulp. The intrinsic pectin can form gels. The principle is the same as for extracted HM pectin. The gelation only occurs when you add enough acid to lower the pH below 3.5. We use texture measurements to study various conditions. Some of the results of those trials are summarized in this graph. This is an excellent tool to use as a starting point when formulating. In this scenario, 2% citri-fi is used. Gelling occurs when the gel strength is at 100 or more. You can see the interaction of sugar and acid on the graph. Higher bricks and a lower pH generate a stronger gel. Below 50%, 55% sugar or soluble solids, the HM pectin type cannot form junction zones needed for a real gel. But of course, under these conditions, citri-fi provides viscosity and much more than cellulosic fibers. As expected, targeted gel strength can be reached by adjusting the citri-fi usage level. My recommendation is to start with 1 to 1.5%. Always, the natural pectin content of your fruit source need to be considered, since this also affects the system. The pH value and sugar content not only affects the gel itself, but also the gelation time. Together with the University of Berlin, we studied this effect by using a special equipment to measure the viscosity during the cooling process of hot food preparations. This technique shows up gel points as function of sugar and acid. The results of those trials are summarized in this table. You can see that increased sugar and acid causes a higher gelling temperature. This is important for very high brick systems, such as baking stable fruit preparations. A buffer system which retards the drop of pH can help if you need to fill at lower temperatures to avoid having pre-gelation in your cooking vessel. I want to review now some basic functionalities of citri-fi before I proceed. So far, I have only mentioned the functionality of pectin, but there is more. Citri-fi has a certain three-dimensional structure, and the insoluble fraction has also a function in the food system. It provides structure and water binding. We offer our citrus fiber in a variety of particle sizes. Depending on the size, you can manipulate the appearance and mouthfeel of your product, as you can see on these pictures. It is important to understand and consider that citri-fi basically is dried fruit pulp. Therefore, it can change your system in a way coarse mashed fruit and fine fruit pulp can do. You don't need to buy special equipment to use citri-fi. There are several ways to incorporate our product in the food system. This natural ingredient can be blended with all dry ingredients, including sugar and acid. Citri-fi also can be dry blended with just 5 to 10 times the amount of sugar, or dispersed directly in sugar syrups. Also, this ingredient can be added by way of making 5 to 10% hot dispersions or cold dispersions. Citri-fi can be used to improve texture and quality of fruit spreads, jams, jellies, and fruit preparations. Those are used in a variety of fruit products such as yogurt, confectionery, and bakery fillings. The same technology is also applicable to certain fruit snacks such as fruit bars or ladders. I like to show you here a practical example which combines two functionalities of citri-fi, gelling and structuring in a cookie fruit filling. We tested citri-fi versus a LM pectin control, a mixture containing both pectin and citri-fi, as well as pure citri-fi alone. In the case of citri-fi, the fruit pulp content was lowered. Calcium is required for the LM pectin, but not for citri-fi. You can see here that the fruit preparation with citri-fi at 1.2 and 2.5% set up gels that are like the pectin control. After baking, you can see that the fruit preps with citri-fi behaved like the pectin control. Despite the reduction in fruit pulp, the citri-fi containing cookies look similar to the pectin control. I want to summarize the benefits of this application because this can be applied to many more fruit applications. A key is that citri-fi shows both benefits of LM and HM pectins, but without their certain disadvantages. There are many benefits for using citri-fi's native pectin to improve fruit preparation, such as easy to use. Citri-fi does not require calcium to activate the gelling properties unlike other ingredients on the market. The preparations can be filled hot, which is another benefit. Also, due to the consistency, the fruit preparation is reversible and pulpable. And when used with other hydrocolloids, there are synergistic effects on texture, viscosity, and appearance. Citri-fi creates a natural appearance and bite versus other ingredients that typically produce gummy textures. And lastly, citri-fi is ideal for clean label and natural products. Let's review a few takeaways from this video. Citri-fi is a natural, non-GMO ingredient which is easy to use. It can be labeled as citrus fiber, dried citrus pulp, or citrus flower. The 40% pectin inside can be activated and is suitable for gelled fruit preparation and spreads. Gelling requires 55% bricks and more, and low pH conditions. The gelling strength and gelling time can be targeted by adjusting the bricks, pH, or the citri-fi usage rate. Citri-fi is available in several particle sizes. This allows you to target specific textures. And this natural ingredient creates a natural looking fruit texture and bite, unlike other ingredients that can be gummy. This concludes the video. If you have any additional questions or need technical service, please contact any one of us listed. Or to learn more about citri-fi, please visit our website at www.fiberstaringredients.com. There are other videos available on our website, so we encourage you to watch them all. Thank you.